for that. Okay, so the first thing we have to do is this is the parent function. Y equals log base a of x. And if we wanted to, we could use f of x. But in this, I'm just going to leave it with y. Okay, so first thing is we see this 0.10. That's just telling us there's no transformation to the graph that we have to worry about. There's nothing that's been added on or it hasn't been shifted in any way. So what I'm going to do, in this case, all I have to do is find my a value. So I'm just going to plug in my xy point. I'm not going to plug in 1, 0. That's not going to tell me anything because every log function is going to go through that point as long as there's no transformation. So I'm going to plug these in. So my y is 2, and then I have log base a, that's what I'm trying to find, of 25. So my y is 2, my x is 25. Now I'm going to rewrite this. And I know that this to this has to be equal to this. So I'm just converting it to exponential form. So a to the second is equal to 25. And then I'm going to solve that. So a is 5. So all that means is my equation is going to be y equals log base 5 of x. So my end equation, just like any equation, is going to have my x and my y in it. So it's like if I plug this into Desmos, I would get this graph. Or I can plug any x in and figure out what the y is. Or plug any y in and figure out what the x is. So that is my answer. Y is equal to log base 5 of x. Let's look at a couple more. Okay, so here I have a graph. Again, it's going through the 0.10, and it's also going through a 0.814. You know, the x is real big, the y isn't very big. I'm going to follow that same procedure where I'm going to plug my x and my y in. So 4 is equal to log base a of 81. Plug my x in and my y. Now I'm going to rewrite it. So a to the 4th is equal to 81. So all I'm doing is I'm using this definition of logs to convert between the two forms. Okay? So I have a to the 4th is equal to 81. I need to solve for a. So I either need to take the 4th root or I need to take it to the 1/4 power. That's equivalent. Or you could think about it, it's really taking the square root twice. However you want to do that. You would figure out that a is equal to 3. 3 to the 4th is equal to 81. And then my equation, I'm just going to plug that a in. So y is equal to log base 3 of x. So I plug the point in to figure out what a is. Okay, we will do one more. Here I have a point, the common point, 1, 0, and I have another point at 2, 1/2. So maybe the fraction makes me nervous, but I'm just going to plug it in, see what happens. I have 1/2 is equal to log base a of 2. Plugged my x in, plugged my y in. Now I'm going to rewrite it in exponential form. A to the 1/2 is equal to 2. A to the 1/2 is equal to 2. To solve for a, couple of ways you could just think about, like the 1/2 power is like taking the square root. So the square root of something is 2. Or you could just square both sides. That's the way I usually think about it. So a is equal to 4. 4 to the 1/2 is equal to 2. So then y is equal to log base a of 4. Nope. That was dumb. The whole point is I found a. So y is equal to log base 4 of x, right? We want our equations to have x's and y's. I was thinking about these numbers. So your equation, you find your base, you plug it into the equation, and you're good to go. Okay, at this point, you would be able to complete homework on page 3, number 4. There's a few graphs to write the equation for.